I just wanted to add a quick note about the difference between the different titles that you might see in software testing. So, if you're looking around, it can be a little bit difficult looking for a job because there's a lot of people that still use software quality assurance. And then you'll still see some things like software tester or software test engineer. And so, what's the difference between these, and how do you go about, you know, angling towards one of them, either trying to become one of them or trying to find a job that matches what you are? So, software quality assurance comes from, I'm not an expert on the source of this, but becoming a software tester myself from the mechanical engineering side, I had some kind of basic quality assurance experience before I got into the industry, and so I was in a manufacturing environment, and I was brought into a company because they had some quality process problems. And so I was to define some tests about the process and try and determine what was actually wrong with their quality, like what were the problems in their process that were causing their quality issues. And so that is a certain part of quality engineering, right? And then there's another aspect of it where I would be taking in parts that we got to use for our manufacturing process. And we would have kind of an intake process where we would do some measurements and determine whether the parts that we got were within spec, whether they were within tolerance. And so I get out my little micrometer and I would do a little measurement and take some average and make sure that the diameters or whatever it was I was measuring were appropriate and within range. And that was a very simple process. You take the measurement, even though there's a little bit of skill in using the micrometer, right? If anybody's used one of those, that can be a little bit finicky. So you have that variable, but really it's just measure it. Does it make it? Yes. Then you move it on, right? And so if you have a batch of 100 of these things and you want to take them in and you measure them, you say, okay, well, if a certain number of them are okay, then you accept the batch, right? And there are military specs for how you can do that we were using. And so that's how you would make sure that that batch is okay. You'd say, okay, we've measured them, this batch is okay. So that feels a lot more like quality assurance. Okay, I've assured that this batch meets our spec. So then, when you get into quality of software, it gets a little bit more difficult, right? Because you're not just saying, okay, well, like I have a tool and I just put the tool on the thing. Does it measure in spec or not? Do I accept it or reject it? Because when you're dealing with software, you get a complicated set of features and functionality. Then you can't just apply a micrometer to it and say, okay, the number says that it's good, right? So you have to do a little bit more engineering in order to make that make sure that that is aligned to what's expected. Does it meet all the requirements? So you're not just dealing with one very simple diameter that you're measuring. That would be one component in within many that you'd be testing for in software testing. And so you have to define what are the important ones to test and how are you going to go about testing them, and controlling the environment in which you're testing them, right? So if I were to measure, just to take this example out a little bit further with mechanical engineering, so I've got a diameter of something and I'm saying, okay, I'm going to accept this from the quality assurance, standpoint. I measured the diameter and it's okay. Now, the quality engineering standpoint would say, like, okay, well, that's okay for now, but if I'm really going to be using this, I need to make sure that the diameter is okay in use, right? And so what would that mean? Well, there will be temperature differences within use. And so diameters can expand or contract depending on the materials. It can do that more or less. And so you could say, okay, well, let's heat this up to, working temperature and see if the diameter is still in spec or not. And then we can say, okay, well, would there be wear over time to this particular part? Could the diameter actually be shrinking, because of wear? And if that's the case, like how much is too little? So would we, how long does it take to wear down? And then at what point would it become out of spec? These are more of the kind of the engineering concerns. So what you're dealing with is how do we make sure that it's going to be okay when it's being used? And that's where it becomes more of an engineering concept. And so I think that's what we're really talking about when we're talking about software quality in engineering, is that we have to look at, okay, here's the software, it's complicated, it's a lots of different parts to it, and now we have to make sure that it's okay when it's being used. And there are a lot of different considerations when you're dealing with software in use, right? You've got users who are doing workflows that weren't expected, and how do they recover from those? And then you've got systems that are supporting these, and sometimes they're running out of resources, or sometimes two things happen at the same time, and the system has a difficult time trying to separate the two of those. They're trying to do the same action at the same time. You get bad results for that, concurrency problems, right? So there are some of those considerations that really take, more of the engineering effort to say, okay, well, say we're going to have a problem if two people are doing the same thing at the same time. How do I make a test that makes that happen? Because, I'm one person. How do I click the same thing twice at the same time? And we're talking within milliseconds of each other, right? Like sometimes the timing for those things are important. So that's where you need to start thinking about, like, okay, I need to engineer a test that's going to do the thing that could cause the problem in the real world when it's actually being used. So that's where it moves over. So there's a contingent of people who are really, they're adamant about the change from the term SQA to test engineering, and I think it's got some good reason. Now we can quibble over terms all day long if we want to, but it is important to recognize that there is a difference there. I think some of it comes down to I can't I can't assure that the quality is there. Like in my receiving process for the parts in mechanical engineering, I could assure that that box of parts that I was taking in met our spec, right? I could say, okay, I've assured the quality of this one. I've rejected those that didn't make it, right? Now in software, you can't do that. You can't just be like, okay, I've assured that this software is of quality because I've rejected the parts that are failing. And so now all we have is the quality. Well, it doesn't work like that in software. And so it's not quite the right process for it. Are we still going to have, SQA as a term around? Yeah, for sure. It still makes sense. And we can reinforce what software quality assurance should be, what that term should be, as far as like, well, we know what the job is, we know what's needed out of it. Let's just reinforce that, and we don't need to pick on the term. So that's my stance. But oftentimes people really feel it's like valuable to call the thing what you think it is, and that helps to reinforce it. So I think it's a strong case in this. I prefer the term, test engineer, and that how you have development engineers and you have test engineers, and we're all working to engineer. And test engineers are focused on the testing part of it, but development engineers are also involved in quality. So it's another reason why you might want to take the quality piece out of it, is because everybody's involved in the project should be involved in quality. So we should have a quality engineer. All of our developers should be quality engineers. They should be focused on developing quality product. And then our product people, they should be focused on quality requirements, and requirements that will ensure that the software is behaving as it should be when it's being used. So we're all quality in that sense, and we're just focused on the testing part of that. And so we're the testers, and that they would be the test engineers, because they have to engineer a different level how to make the tests to expose the problems that we care about. So just wanted to add that side note. So thanks for letting me put that in.